Let me take the third question of that page number 21. It says x plus 2y plus 3z equal to 6, 2x plus 4y plus 6z is equal to 12, 3x plus 6y plus 9z is equal to 18. Do you not see the first equation simply getting multiplied by 2 to get the second equation, and simply getting multiplied by 3 to get the third equation? Which means of the given number of equations, how many are genuine? Only one. If I'm going to say that the rank is 1, the system is consistent, but it will have infinitely many solutions. I'm going to do the fourth sum now. The sum says x plus 2y plus 3z equal to 6, x plus y plus z is equal to 3, and 2x plus 3y plus 4z is equal to 10. What do you see in this, guys? What do you see in this?
And the first two will get the third one. No.
First one is genuine, second is genuine. Adding the left hand side of the first and second gives you the left hand side of the third, but the right hand side gives you
contradiction.
9. It is written as 10, which is a contradiction. So I can say that it is inconsistent or no solution. Okay, this is inconsistent. So even when you try finding rank, it will contradict itself. That is what we're going to do it using rank method and others. Okay.
Yes, sir.
So is there a rank for this? No, actually speaking, no. There is going to be a contradicting rank inside. That's why we call it as no solution. We're going to do it all when you do the process. Got it?
Yes, sir.
Yeah. Now. So now let us enter into the process one by one. Okay. The first thing is to find out rank of a matrix. It is a 6-mark question. Okay. There are several ways to find rank. Okay. As the definition says, definition of rank is
Number of consistent.
order of the highest non-vanishing minor. Order of the highest non-vanishing minor is the rank definition. Obviously, as we can't understand all this. Okay. Once I explain it to you, maybe after that you will understand the meaning of what you mean by order of the highest non-vanishing minor. Okay. Guys, this is important. If you have any matrix, your matrix is given in curved brackets. If you have any matrix, say for example 1, 1, 1, 3, 2, minus 1, 3, 4, 5, minus 1, 7, 11. Know that this matrix has got 3 rows and 4 columns. Okay, we call this as row 1, row 2, row 3. 3 rows and 4 columns. Column 1, column 2, column 3, column 4. Okay, this matrix has got 3 rows and 4 columns. Okay, now I'm gonna try something with this. Look at this. If I try to take the biggest determinant out of it, take a what? Biggest determinant. Okay, the order of this matrix is 3 by 4 because I told you 3 rows and 4 columns. So the order of this matrix is 3 cross 4. What is the maximum square that you can take outside? Can you take a 4 cross 4 out? No. You cannot take a 4 cross 4 out. The maximum that you can take is a 3 cross 3. Say like this. As a minor. And what is a minor? A minor is a determinant. Straight lines. Within straight lines we have to put. So 1, 1, 1, 2, minus 1, 3, 5, minus 1, 7. Can you understand? What is that I have done is, in the given matrix, a 3 cross 4 matrix, I have tried taking a maximum order out of it, which is a 3 cross 3. Okay, and what is it I'm going to do? I'm going to check whether the value of this is 0 or not. Okay, how will I do it? Maybe like by expanding. Say suppose I expand this 1 into minus 7 plus 3 minus 1 into 14 minus 15. We know how to expand, right?
Yes, sir.
Plus 1 into minus 2 plus 5. Once I expand, I get to know that it is giving me minus 4 plus 1 plus 3, which is what is minus 4 plus 1 plus 3? 0. Oh, what has happened now? This 3 cross 3 minor vanished. This 3 cross 3 minor vanished. Let me take another 3 cross 3 minor, maybe this 3, and check. You know what? Even this after calculation is going to vanish. It's going to become 0. Even if you want, you can take this, and this column as a 3 cross 3 minor. Anything of that sort. Okay, you take any 3 cross 3 and check if it is becoming a 0. Yes, it is all becoming a 0. Can I now get to say that all the 3 cross 3 minors vanish? Yes or no? The previous case, all the 3 cross 3 minors vanish. What was the definition for rank?
Highest non-vanishing.
Order of the highest non-vanishing minor. Oh, which means because 3 cross 3 minors all vanished, the rank of the given matrix cannot be 3. Because all of them vanished. Then maybe I have to go for 2 cross 2 minors. Maybe take these people. 2 minus 1, 5 minus 1, or any of this. Any one if non-vanishing also. Okay. So what is 2 minus 1, 5 minus 1? If it is taken as a matrix, 2 minus 1, 5 minus 1, it's going to give me minus 1 plus 5, which is a 3, which is not a 0. Yeah. Is there at least one 2 cross 2 minor which is not vanishing? Yeah. Therefore, the rank is 2. Therefore, the rank is 2. Can you understand? Therefore, the rank is 2. What that I have done? This is called finding rank using determinants. Using determinants. Determinant method. Who are minors basically? Minors are basically determinants, no? That's why they have values. Determinants only have values. Matrix does not have value. It is simply arrangement. Okay. So is this the way that we find out the rank? Yeah, this is one of the way. Is there an easier way, or is there a matrix way of finding? Yes. We call it as echelon method. What method? Echelon method. Okay. To find rank, and also to solve, we can use echelon method or rank method. Even to find rank, you can bring the matrix in an echelon form. What is an echelon form? Know that basics first. Any matrix given to you, you can keep on doing something called elementary transformation. What you can do? Elementary transformation. Sir, what is elementary transformation? Say for example, let me take 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 1, 5. You know what? I can do something called elementary transformation. What is elementary transformation? I can write any row as, say this is row 1. If I want, I can write hereafter row 1 as row 1 plus row 2. If I want, I can write it as, then hereafter all the row 1 elements should be written as row 1 plus row 2. Yeah, row 1 plus row 2, which means 6, 8, 10, 12. Allowed. The others can be left as such. What is it I have done? I have done one elementary transformation. Is that going to affect the matrix? No. What such a matrix I have got, what is it called? It is called an equivalent matrix of the previous one. It is an equivalent matrix. Okay. So any such number of elementary transformations allowed? Allowed. And is it okay to do between columns? No, don't do between columns. Why? Because eventually now we know that we are talking about equations. It is okay to talk about relationship between one and another this fashion, not this fashion. Yes or no? Not in column wise. Along row wise, there can be relationships. So it is better not to touch column transformation. Only do row transformation. Okay. Now the same previous question, which we got the rank as 2, remember? that 1113 question. Let me do the same question using echelon method or echelon form method. Okay, but by the way, I didn't tell you what is exactly echelon form. I told you what can be done to get echelon form. You can do elementary transformation to get echelon form. Okay, sir. So what is an echelon form? Any matrix can be converted to another matrix where the first element has to be a 1 followed with anything. The next row first element has to be a 0 followed with anything. The next row first and second element has to be a 0 0 followed with anything. Is this called echelon form? No, one more condition. What is that one more condition? 1 0 0 0, and apart from which, if you have say 3 zeros before a non-zero value, then the next row must have 4 zeros. If it is 0 0 0 3 and 0 0 0 6, no, it is not allowed. Even this is not echelon's form, not allowed. Okay, if I have 1 0 0 0 0 0 0 0 0 0 0 0, allowed? Allowed. Why? Because there is no non-zero element occurring at all. Here also. So this case allowed. Here also 4 zeros, here also 4 zeros, allowed in this case. But if it has got a 3 here, is this allowed? No, not allowed. Sir, what is that you can do? One more simplest elementary transformation is there, that is swapping. So what do you mean by swapping? If this is R2, if this is R3, if you want, you can always interchange R2 with R3. Why? To get echelon form. Okay, so I'm going to get back to this question now. This question, I'm going to take and process it. Is it okay? I'm going to take this question and process it. Yeah. Right. 1113, 2 minus 1, 3, 4, 5 minus 1, 7, 11, right? Okay, let me take the question and do it. 1113, 2 minus 1, 3, 4, 5 minus 1, 7, 11. I'm going to do any number of elementary transformation to get it to echelon form. Okay, let me do it now. The first element happens to be 1, so I'm not going to touch this row. Let me go for the second row. I want a 0 here in this place. So what I'm going to do is, I'm going to say R2 can be written as R2 minus 2 times R1, because I'm checking with this 2 at 1. Oh, which means, can I just multiply the first row with 2 and subtract from this? Yeah, I can. So the first row is untouched. The second row is now going to become a 0 in the first place. And here again, if I multiply this with 2, I get a 2, and subtract from here, I'm going to get minus 3. If I multiply this with a 2, I get a 2. If I subtract from here, I'm going to get 1. If I multiply this with a 2, 6. If I go to subtract from here, minus 2. And last, I want R3 also to be changed. I'm going to write it as, R3 can be written as R3 minus 5 times R1. So if I do that, I'm going to end up getting, this is going to get multiplied with 5, so I'm going to get a 0. This is going to get multiplied with 5, and I have to subtract from here, so I'm going to get a minus 6. I'm going to subtract from here. I'm going to multiply with a 5 and subtract from here, so I'm going to get a 2. I'm going to multiply with a 5 and subtract from here. I'm going to get a minus 4. So have I got into echelon's form? No. One step over, second step over, maybe one more step is there. I want a 0 here. Okay, and always, once you have got 2 zeros, you have to only process between these 2 rows. Okay, which means the next step is going to be 1 1 1 3. I'm not going to touch that. Even the second one, I'm not going to touch that. The third one, what if I multiply the second row with a 2 and subtract from R3? Okay, so can I say R3 can be written as R3 minus 2 times R2? Yes. So it's going to be a 0 because 0 process with a 0 is going to be a 0 always. This is going to give me a 0. This I have to multiply with a 2 and then subtract. So it's going to give me a 0. This I am going to multiply with a 2 and subtract. It's going to give me a 0. Wow. What is it I got? I got it in echelons form. Okay. Now, how to calculate rank? Even if there is one element which is non-zero, that row is counted. So this row counted. This row counted. Is there at least one non-zero value? No. Not counted. So counted. Totally 2. The rank of the given matrix, considering that as A, is 2. Can you understand this? This is what we previously got using determinant form.